In this video, we'll be learning how to create and use a two-way frequency table to answer questions. So before we start building two-way frequency tables, we need to talk about what a two-way frequency table actually is. So by definition, a two-way frequency table is a frequency table that displays data collected from one source. So in this case, we can see that the source is students, and that source belongs to two different categories. So here we can see we have two different categories of class, which includes sophomores and freshmen, and mobile access, which includes yes or no. One of the categories is represented in rows, which you can see right here with class, and the other one is represented in columns. So really what we're looking at here are we have sophomores and freshmen, and we're kind of trying to break down their mobile access. So this is our two-way frequency table, and what we're going to do is we're going to be practicing building these from data. And then from there, we're actually going to start interpreting the data and answering questions about that data. So as we build these two-way frequency tables, what we'll be actually doing is we'll be finding joint and marginal frequency. So by definition, joint frequency is each entry in the table is called a joint frequency. Now it's a joint frequency because it's tying together two details. So for example, this box that I just put in red. This is a joint frequency. Remember, the word joint kind of sounds like together. We are joined, basically. This box right here is a joint frequency because it talks about sophomores that said yes to having mobile access. Then over here, in this second box, in this purple one, it's joint as well because it's sophomores that said no. It has two categories. This box here is freshmen that said yes, and this box here is freshmen that said no. So those four boxes are what you call your joint frequencies because they have two categories that they belong to, and we're showing the joint frequency. How often do both of these situations occur? Then from here we have marginal frequency, which is the sum of the rows and the columns in a two-way table. So you'll see that I added on this row here and this row here, and that was to show you your marginal frequencies. So marginal frequencies are finding those totals. So we found that, 118 kids said yes to mobile access. They only have one category. 34 said no. Again, we're now focusing on just one category at a time. These are the marginal frequencies for mobile access. Then over here are the marginal frequencies for each grade. So we can see that 77 sophomores were interviewed, as well as 75 freshmen. And then finally, with all of this data written down, we can then conclude that we have 152 total students. And if you look here carefully, you'll notice that these numbers, while we added down, added across, if you look here, 77 plus 75 gives us 152 students, as does 118 plus 134. So it all adds up nicely with math and shows how all of this data and all these numbers are interconnected, so you can find joint frequencies, marginal frequencies, or find a total number of students. So let's go ahead and now practice this. So it says, you conducted a survey that asks 286 students in your freshman class whether they play a sport or a musical instrument. So we have sport as one category or musical instrument as another category. So what I'm going to start off with here is with this first category. I'm basically trying to figure out whether or not kids play a sport. So I'm going to write down the word sport here. And then I know that I'm going to have probably two boxes coming off of that. So if I draw the boxes off, they either play a sport or they don't. So I'm going to write down, yes, they play a sport here. No, they play a sport here. So those are my categories running with the rows. So I know that I'm going to continue to have information running out this way. Now my second category is musical instrument. Do they play a musical instrument, yes or no? So I'm going to make that box there to start noting off how many kids play a musical instrument. And then I'm going to have answers of yes as one option and no as another option. So there is my two-way frequency table. Now what I suggest you do is, even though it's not required all of the time, I always suggest you go a little bit further and you always do your totals at the bottom as well, because for me personally, that makes things easier to track and confirm, and it makes my data easier to interpret as well. So here I'm just going to put a total box. Here I'm going to put a total box so that I can look at both marginal and joint frequencies. So the first thing that this says is it says you conducted a survey that asks 286 students in your class a question. Well, that's going to be our total of students, which is down here. So that's 286 students total that we interviewed or that we surveyed. So we have our total number of students there. Then from here it says 118 of the students play a sport, and 64 of those students also play an instrument. So we've got two pieces of information here. We've got 64 students who play a sport and an instrument. That means they're going to check off yes in both of these categories. So what they've just given us here is our 64. We know that there are 64 students that do both. We also know that there are 118 students that play a sport. Now, if there are 118 students that play a sport and 64 of them play an instrument, that means that the remaining students do not play an instrument. So I can take my 118 and subtract 64 out to find that value. So I have 118 minus 64, which leaves me with 54 students who play a sport but do not play a musical instrument. And then from here, I know that my total is 118 students playing sports. So notice how that all kind of lines up. We have 64 plus 54 equals our total of 118, and we were able to use all of that data very nicely. So this next part here says 93 of the students do not play a sport or an instrument. So what that's telling me is that the box that corresponds with no and no has to be 93, because that's how many students do not play a sport or an instrument. So we have 93 right here. So while it seems like we might not have enough information here, we actually do, because we can kind of use some logic skills to fill in the rest of this table. So here, what I can figure out is this box, because I know that 54 students and 93 students do not play an instrument, and I've accounted for both of those with sports. So if I add 54 plus 93, I find that 147 students do not play an instrument in any way. Now, because I filled in that box, I'm able to focus on this one next, because all of a sudden, well, my total number of students, right, the number that play an instrument and the number that don't, need to add up to 286. That has to be a fact. So what I can do is I can take 286 and I can subtract out that 147, which leaves me with 139 students that I know play a musical instrument. Well, now because I know that, and because I know that 64 students are yes to sports and yes to instruments, I can now take 139 and subtract out the 64 and find that 75 students play a musical instrument but do not play a sport. Finally, the last piece I need to find is how many kids do not play a sport, but that's pretty simple because I already have that column or that row with all that information. I know 75 kids play an instrument and no sport, and then I have 93 kids that aren't involved in either. So if I take 93 plus 75, I end up with 168. Now what's cool there is if I double check, these two numbers right here are going to add up to the 286. So this all comes full circle, and all of those boxes match up and align together so you can fill in all the information, and now we can interpret this in any way that we see fit. So let's try one more example here. It says you survey students asking if they have a job. 75 males respond with 18 of them responding no. 57 females respond with 45 of them responding yes. Organize the results in a two-way frequency table. So first thing I'm noticing is we have two categories. We have whether somebody is a male or a female, and then we have whether or not they have a job. So let's do here gender. So that's our first box. And then here, branching off of that, we're going to have males and we're going to have females. So there we have that first category all filled in, and then we can continue that on if we would like. So then from here, our second question is job. Do you have a job? And if we look at that, we have two options. We have yes, I have a job, or no, I do not have a job. So there's our two-way table. Now I'm going to add the totals in again because I think the totals are very helpful. So we have a total here, and then we have a total box down here. And now we can start filling in our information. So the first thing that I see is that 75 total males were surveyed. Because 75 total males were surveyed, that piece of information is going to go here into my total box for the males. Now it says that 18 of them responded no, so I can fill in that box right there to start. And then what I immediately notice is that if I know that 18 of them said no, all I need to do is use subtraction to find how many of them said yes. So here if I take my 75 males and I subtract out the 18 that said no, I find that I have approximately 57 males left over that yes, do have a job. Now from here I can use the next detail to help me out to get the second row. We know that we have 57 females total, so that's going to go over here in our total box. And that 45 of them responded with yes, that they do have a job. So similar to the row up above, because I know two of those values, I can say, well, I have 57 total females, and I know that 45 have a job, so by just using subtraction, I find that 12 of them do not have a job. Now from here, I can actually fill in these last couple boxes by just adding straight down. So here I can see that the number that yes have a job are 57 and 45. So if I add those together, I find that a total of 102 students have a job. I can then add straight down with the 18 and the 12 to get 30, to find that 30 students do not have a job. And then what's really cool here is if I've done all of my calculations correctly, if I add these students together and these students together, which they're the same students, so they should total the same amount, if we take 75 plus 57 and 102 plus 30, we end up with a total of 132 total students, regardless of the way that you add, regardless of the angle you come from. So here now we have a full two-way table, and now we can start to make, some assumptions about the data. We can start to analyze the data and answer questions about the data.